So, what do you think? Let's see. Student subjects are instructed to hold their arms above their shoulders as long as they can. Meanwhile, the electrical activity in their arm muscles is measured. This is an observational study. Yep. It'll be like this. Which of the following statements is true? Okay. So we're looking for stuff that actually is real. I have to tell myself that when I do these questions. I have a tendency to do what's false when they ask me what's true. Just so I don't know. Maybe I'm defiant. So, non-response can cause bias in surveys because non-respondents may behave differently than people who respond.
That's true.
I think that's true. Let's see. All right. So we'll keep this in mind, possibly. All right. There might be a more true one. It's weird, right, with these things. There might be one that's better. Bias arising from undercoverage can be compensated for by increasing sample size. No, because we're talking about, right, with undercoverage, we're talking about not representing like a certain group that's in the population, right? You'd have to be more, yeah, you'd have to be more specific about how you're increasing your sample size. So that one's no. Stratified random sample is often employed to reduce the impact of response bias. So response bias is when people lie, right? Or when they're not honest, their responses aren't honest. So that stratifying is not going to help you prevent people from lying. All right. People's responses to survey questions tend not to be influenced by a right. That's definitely gonna. What?
That's a joke.
Okay.
Jesus.
Okay, sophisticated statistical methods can always correct the results if the population you are sampling from is different from. No. I mean, you gotta always sample from the population you're interested in. All right, cool. So we spent a lot of time talking about stuff, and A was indeed the answer. But it's the whole point of this is to talk about stuff. All right. Cool. In an experiment to measure the effect of fluoride varnish on the incidence of tooth cavities, I guess you gotta be specific. All right. I've never heard them called tooth cavities. That's weird for me. But I guess there are other cavities. So, 34 10-year-old girls whose parents volunteered them for the study were randomly assigned to two groups. One group was given fluoride varnish annually for 4 years along with a standard dental hygiene regimen. The other group only followed the standard dental hygiene regimen. The mean number of cavities in the two groups was compared at the end of the treatment. Everything sounds good except for one thing so far. Which of the following is a problem with this experiment? Were they randomly selected? Yep. So that's not true. There was no control group. I believe that there was. Yeah. Yeah. All right, cool. There was a control group. The absence of replication increases the impact of random variation. I mean, 34 assigned into two groups. I mean, it's not a lot. Insufficient attention to this placebo effect. Yeah, I don't know how the placebo effect is going to affect you getting cavities, right? Like,
I think it's
itchy. You can't limit it to girls. That's. Now, if they were to say to measure the effect of fluoride varnish on the incidence of tooth cavities in girls, then you're good, right? But because they didn't say that they were just looking at girls, you have to include boys as well. Although, I mean, yeah, the problem is either of these look okay, right? But I think this one is the one that's the most glaring problem. I mean, there wasn't any attention to the placebo effect, I guess, right? They didn't give them a placebo varnish, right? Which, I mean, you could get swayed in that direction. And then there was not a lot of replication, but there was a best answer. All right, table of random digits. Scientists. Measuring leaf litter and a random sample of forest sites. They're labeled up to 45. She starts at the beginning, and okay, so we want a sample of 5. So we're looking for numbers 1 to 45. So we chose 38. We did not choose 68. We chose 35. We chose 2. Not 79. We chose not 38 because that's a repeat, right? Then we chose 22. Where are we at? 1, 2, 3, 4. One more. So 45, so 40. All right, so show me 38, 35. So 2 and 22. Yeah. All right. It's not too bad.
A lot of it's kind of free.
Yeah, there's 0 math
It's
involved,
just kind of like
which is great. They'll get into probability here soon. That'll get mathy again.
Just the test tomorrow.
Yes, tomorrow. All right. Testing the reliability of traffic signal controllers produced by 2 different companies. We've got 20 sets of controllers, and it's going to install them at 40 different intersections in the city. He's randomly assigning controllers. Let's see. Company A is going to go to 20 intersections, and Company B to the rest, right? The reason why we're randomly assigning is because I don't think that's a good reason. I'm gonna jump around. That looks ridiculous right there. This is also not good. I actually feel like I don't know. Maybe I should not make that yet. Although I really don't think it's no. Well, that doesn't make sense. We don't randomize so that things are easy to put in a computer. That's really weird. That's possible. Alright, so now the question is, are we creating 2 groups of 20 intersections that are similar? We haven't even classified them, right? I feel like a method of creating 2 groups that are as similar as possible would be blocking, right? In order to get them to be as similar as possible, we'd really be talking about blocking and not randomization. So let me go with that. All right. Cool. Okay. So to test the effects of a new fertilizer, 100 plots were divided in half. Fertilizer A is randomly applied to one half and B to the other. This is not an observational study, right? Because it seems like you're doing an experiment. We are going to be comparing. All right. All right. So I'm going to skip these two because they seem they both seem kind of plausible. B and C. But D, let's see. Is there any blocking? So were they divided according to some characteristic? No, they were not. Yeah. All right. So let's see. Completely randomized? I mean, it was random, but is there a more specific thing that was happening? So I don't know. For this, I gotta imagine what's going on because there's something weird happening here. Let's assume that there are 100 of these, right? 100 plots. They decide to. Well, I guess I'm gonna have to have one more for another right in half, right? Say, hey, you guys get fertilizer A, you guys get fertilizer B. Now, if we assume that this is all the same type of land, then this will be a matched pairs design. I wish I knew, like, if it was a big amount of land or a small. If it's small, then it'd be safe to say that everything is kind of the same, right? So I think I'm going to go with B. And actually, the answer is B. I feel like this question doesn't give you a lot of information. I feel like you have to make a couple assumptions, right? That you have to assume that the plots are fairly small, which would mean that they would be fairly homogeneous, right? If you had a small plot, they should be pretty much, you can make it pretty much the same. And this isn't really something we've ever even talked about. We've never defined it as being a completely randomized experiment. So there you go. All right, we're going to assess customer satisfaction, choosing a random sample of 10 of its flights during a single month, and ask all the passengers on those flights to fill out a survey. This is an example of a cluster sample. Makes sense, right? You're sampling a large group of people, so yeah. I really didn't think that there's much more we need to talk about that. It's definitely not that. It's definitely not a simple random sample, right? Because we're doing groups and so on. So I think we talked about, and I'm not even sure, it doesn't even come up in our discussions ever. So, all right. And another thing is if it looks like, if it's a fairly unfamiliar term, pretty much count on it not being one of your answers. These tests have a tendency to only stick with the things that we've mainly focused on talking about blocking, stratified random sample, cluster samples. All right. Yes, I work for an advertising agency. I always wanted to work for an advertising agency. We're going to design an experiment. We're going to look at if these commercials are effective. So we're going to be shown one of the 3 versions. We're going to ask the attitude, okay, you think there might be large differences between women who are employed outside the home and those who are not. This is weird. Because of these differences, you should use. All right. What should you use? It's an experiment, right? So, right, you're going to go between these two because they need to separate by some sort of difference that could affect the outcome. But this one refers to, so this is a sampling technique. Quit. That's the only way I can spell that. And this right here refers to an experiment, right? So that's why I don't choose that. You should use a categorical variable. And they keep doing this multi-example thing. All right. Ooh, still going. Okay. In 1990, they did a census, not a sentence, although I probably did that too. People who fail to complete high school tend to have above average number of infant deaths. That's really sad. In other words, there's a positive association between X and Y. The most plausible explanation for this is there's a lot of crazy stuff there. Let's see. X causes Y. Programs to keep teens in school will help reduce the number of infant deaths. C or D? Yeah, that's where, let's see, Y causes X. Programs that reduce infant deaths. Yeah, so definitely not that one. Other variables may be confounded with variable X. For example, say just large populations. Ooh. Of both larger populations. Ooh. I like that one a lot so far. Both variables are directly. Yeah, cancer's got nothing to do with it. So, especially because we're talking about infant deaths. I'm pretty sure cancer doesn't cause a lot of infant deaths. It probably causes some in some way, but I would imagine that the majority of infant deaths are due to some other sort of complication other than cancer. I don't think you can say it's completely coincidental, and we're gonna go with C. It makes more sense. So we can't really say that there's definitely an association between X and Y. We need to be able to compare some data. So there could possibly be some. Alright. And we needed a question about compounding anyways. We haven't gotten one. So there we go, right? I saw a term there, compounding, and I was like, ooh, compounding. That's something to learn about. Well, that's the way I take tests. Anyhow. We will have to take a test today. Let's see. We got 80 volunteers. Okay. They use a certain brand of over-the-counter medication. They were recruited. Let's see. Okay, there we go. I was looking for this word because until then there was a problem. Alright, so they were randomly assigned to one of two groups. They're going to take their current medication, and the other one is going to do a new experimental medication. Each is asked after 2 weeks if their allergy symptoms are worse, better, or about the same as they were at the start of the study. Okay, what can we conclude? I am not sure about this. Can we? We can determine whether the new drug reduces symptoms from the old drug. For anyone who suffers from allergies. Oh, yeah, so no. Sorry, my bad. I like this one because we're talking about more specifically the subjects in the study. I don't think that we're going to be able to generalize the effects to the population. These are volunteers. I don't believe there's any indication that they did anything to make sure that they represent the population that takes this medication. We can determine whether the allergy sufferers symptoms improved more with the new drug. Huh? Yeah, I don't think so either. I like that. Thank you. We cannot draw any conclusions since all the. No, that's not true. It doesn't matter that they were all taking the old drug. There was indeed a control group, right? So we're gonna go with this. And the reason why I chose B again instead of A would be because there wasn't really, it doesn't look like they paid any attention to making sure that the sample represented the population. They were just kind of people that volunteered themselves, and then they didn't separate them out. All right. Hey, we did it. Look at that.